Hello folks, I am Ed Overstreet and welcome to the Night Sky Imaging channel. We're currently working on PixInsight software, the M16 Eagle Nebula. We are on step 3 and where we're going to look at color calibration, and that will be all we'll be able to cover in this step. It will take a little time to do that. So we're going to look at 4 different ways to calibrate for the color, and you can decide which one you like. I already know the one that I like, and so let's get started. I have opened, let me go back to PixInsight, and we need to share my screen so you can see it. Wherein we in step 2, when we ended step 2, we had taken our linear image that had been cropped and had the dynamic background extraction tool play, and then we also ran MLT to while it was in a linear state, to manage the noise and remove some of the noise, and it did a nice job of doing that. So if you look at this image after the noise and this image before the noise, and we compare the two, why won't it do that? Oh, it did do that. Let's do it again. Okay, and if we compare the two, you're going to see that this is noisy, and this has a lot of that noise removed. So now we're ready to color calibrate the image, and what I want to do is I'm going to take I made a clone of this and I'm going to make 4 more. I don't know if I have 4 of them, but if we don't, we'll create another one. Alright, and so it doesn't matter which one we start with. Let's just start. So let's begin with using color calibration by PixInsight, and you can find that by going to Process, All Processes, and come down here to Color Calibration. I save this as a process because I really like the tool, and I use it I used to use it all the time. I use it less because I've become a fan of photometric calibration. But let's do this. We're going to do this 2 different ways. We're going to use structure detection. We're not going to add a reference image. We're just going to let all the structure, the stars and the nebula, be used in order to calculate the white balance. Then we're going to create a background preview, and let's find some background that we can work with, and this works probably as good as anything. And so we will then go to the background reference part of color calibration, and we're going to go down to preview. So we've added this preview. Now we just drag this over and drop it on our image, and this is, let's stretch this again and take it a minute. And this is calibrating the image using PixInsight's color calibration, using all the structures as your reference image and finding some background to use as your background reference. I make no upper or lower limits. There's no need to do that. And then we run a process into, we drop this triangle process into our image. And so this will be, we're just going to call this one color calibration with structure. And we'll get rid of our preview and we'll put this up here. Now let's bring up another one, and this time we are going to find a reference image. So let's zoom in on a star that's white, and that's not blown out. And so here we have a star that's not blown out. It's pretty good size, so it should give me a preview. So I'm going to go up and click on my preview, and that's going to be my white reference. So I'm going to click on, and let's see, this is MLT clone preview. So we've got this reference tied now to this preview. And then we want to go back and find us a background that we can hang on a minute. And let's get us a preview, and let's go right here. And that'll be preview 2. So let's go find preview 2. And again, with nothing being changed, we're going to drag the process over to our image, and it has completed. And so we're going to stretch it. And this is color calibration. Let's get rid of these previews. Preview, delete all, and this is going to be color calibration. And what this implies is that that is without structure. We're going to drag that over there. Then we're going to borrow a script from Hartmut Bornemann, and it's called AutoColor. And we're going to go to Script, Utilities, and click on AutoColor. And as soon as I do that, it's going to start running. So what I want to do before I do anything is I want to run you over to a website by Herbert Walker. And he has scripts by Hartmut Bornemann. And these are some scripts that I use. One is the PSF image. If you click on it, you can download it and then add it to your scripts. Another that you want is AutoColor. That's what we're getting ready to run. And then you want the point spread function image. So you may want more, but for my workflow, I use the PSF image, game, and AutoColor. So with that being said, I would suggest that you make note at skypixels.at, and then scroll over to these scripts by Hartmut Bornemann. Okay, and now let's head back to PixInsight, and we're going to run his script called AutoColor. Okay, AutoColor has ran, and we want to stretch that again. And this is a brilliant script. We're going to change the identifier here to add that here, and then we have the last one, which is really what I've become the most comfortable using for reasons that just make me feel like I have really imported the actual colors of these stars from photometry catalogs, which is in fact what's going on. So the first thing that I'm going to do is I'm going to open up the process called Photometric Color Calibration. You can find that under Process, All Process, and Photometric Color Calibration. I would recommend that you screenshot and copy these settings, with the exception of image parameters, because this is where you're going to put your settings. Also, I would recommend that you download catalogs. I have several installed. I default to the Gaia DR2, but I let automatic catalog, I let it choose, and then the and this is for plate solving, because this software is going to have to plate solve first, and then once it's done that, then it's going to reach this APAS catalog, which has the correct colors for all the stars, and it's going to apply those colors to these stars. So it takes the guesswork out of any of these other scripts, and it should more accurately render a true account of what the star colors should be, and balance this image accordingly. So these the APAS and the Gaia directories can be found. The links to them are on my website. They're on Atom Block Studios website, and of course you can Google them, but I suggest downloading and installing. And on the PixInsight forum, I've seen the links to them as well. So I would recommend that you install those. If you choose not to, you can still run Photometric Color Calibration. It takes a little longer because it's going to reach out to the internet and find these catalogs, and it's going to run them online, if you will. But if you can download these to your computers and they're installed, this process runs a lot quicker. Okay, the first thing you're going to want to do is you can leave narrowband alone, and it defaults to an elliptical galaxy. That's fine regardless of what you're imaging. Just leave it alone. Leave everything else alone. If your filters are 6 nanometers, which mine are, fine. If not, change them to what your filters are. You can leave the database at Strasbourg, France. Apply color calibration to the image. The first thing I do is I'm going to search the coordinates, and I'm going to type in M16, and I'm going to search, and it found it, and I'm going to get it, and it will populate the RA and DEC. I want to check both show compound angles and show RA in time units. The observation date, if you click on acquire from image, if your software writes that data to your images, then it will pull that image in. If not, you just add it manually. But in my case, my Sequence Generator Pro does not write that data. So I also have to put the focal length and the pixel scale so that we can plate solve. And the pixel scale for the ASI 1600 mm Pro is 3.8, but the focal length of my telescope is not 678. It is actually at one half of that, around 336. Now, the reason why I double it is because I am undersampling and I'm going to drizzle 2 times. And so in order for this image in order for the parameters to do an effective job, I really need to double this. And so if you're undersampled, and if you choose to drizzle, and if you have a 300 millimeter focal length, make sure this focal length is 600. And so if you're not drizzling, just use the actual pixel size and focal length of your optical tray. I keep automatic catalog checked. I check distortion correction, and automatic catalogs collect is I change nothing under advanced plate solving parameters, but this is everything I have. So again, you can screenshot. There's no need to change the levels on brightness, and just go from as dark as it can get to as bright as it can get. And that's it. Everything else stays the same, and then you just drag this triangle over onto your image and let the photometric calibration do its thing. Okay, it is finished, and let's unstretch and then run a screen transfer function. And this is the photometric calibration there we go, finally. Alright, so let's take a look at each one of these. To make these a little somewhat similar for comparison. Okay, this is the color calibration with the structure detection. This is the color calibration where I used a star as a white reference, and we had the background as a preview for both of these, but here we used structure detection. Here we used what we hoped to have been a white star. And then this is the Hartmut Bornemann script, and it is the most different of the three. It doesn't have as much green bias as the other three, and a little more blue is showing up. And then this is the script for the photometric calibration, where both plate solving to identify where these stars are, and then photometry to retrieve the actual colors of the stars and apply that to that effect to the stars. So visually, I actually like AutoColor by Hartmut Bornemann, but I'm going to experience-wise, over the past images that I've processed with the photometric calibration, I have been the most impressed with what that process returns. So that's where I'm going. So I'm going to save this one and put that here. I'm going to close this, and close this. And actually I want to make a clone of this, and then we put that back. Now for the time being, I'm actually going to set that over here, because this is our workflow will pick up again, and we will stretch this image and convert from linear to non-linear. But before we do that, we're going to run deconvolution on our luminosity layer, and that will be in our next step. So hopefully this will give you a better understanding of different approaches to color calibration, using the color calibration tool in PixInsight, using Hartmut Bornemann's script AutoColor, or using the Photometric calibration in PixInsight, and using Photometry along with their plate solving software to do the color calibration. They're all, well, I think the color calibration steps are the fastest. It takes a little longer to run AutoColor and a little longer to run Photometric calibration. So if you're in a hurry, I would just stick with AutoColor. If you want precise color calibration for your stars, I would lean towards Photometric calibration. So with that being said, I'll catch you on the next video, where we will look at convolution and how I would go about running the deconvolution on my luminance layer. Make sure you say something nice to someone today, and I know this for a fact: you're going to feel better for doing it, and they'll feel better too. Have a good day.